If you got the graphs of sine and cosine down, I don't think that the rest of them are going to be very hard. Hopefully you've had a chance to practice those, ask questions on them, and you understand, especially that 5-point summary, okay? And so we're going to graph the other trig functions today. Today, this video at least, is just going to handle tangent and cotangent. And just like we did with sine and cosine, guys, I'm going to bore you to death with a big O XY table, okay? Great big XY table. I'm going to count it by pi over 4s again. Oops. Oh, I wrote the wrong one. Shouldn't have used black, and I see myself quickly approaching this black at the bottom of the screen. And I run out of room. And 2 pi. Now, obviously, this is overkill. My goal is to not only just shorten this table like we did with sine and cosine and knock it down to 5 points, but make it so you don't even have to draw a table at all. I think this is going to look similar to what you have seen before. So first up, I'm just going to go grab these values off of my unit circle, off my sine, cosine, tangent table. I get 0, 1, oh, right there, look at pi over 2. Something weird happens at pi over 2. On that unit circle, if I take y divided by x, I got 1 divided by 0. Gave me undefined. Okay. That's all right, though. I have to get undefined there. So I got 3 pi over 4, it's negative 1, 0, 1, oh, 3 pi over 2. I'm dividing by 0 again on my unit circle. Ah, undefined. It's all right, it'll buff. Negative 1 and 0. So let's see what we have here. If I translate these points over 0, I'm going to count this as 1 as well. 1. I think it's something that's undefined. Man, what am I going to do with that? So then I got negative 1, 0. I'm putting negative 1 down 1. And then 1. I got something that's undefined. Yeah. Negative 1 and 0. So I'm counting by pi over 4s here. So that means that pi over 2, something weird happened. At pi, I got this x-intercept. At 3 pi over 2, something weird happened. And then at 2 pi, I had another x-intercept. Let's backtrack a little bit. All the way back to October, November. Remember that we said that tangent was simply going to be sine x over cosine x. Well, anywhere that makes the bottom equal to 0, which is what I had when I had pi over 2 and 3 pi over 2. I had 1 divided by 0 because cosine was 0 there. That gave me a vertical asymptote. And that's exactly what's going to happen right here at all of these undefines. And so even if I backtrack a little bit, I know it's not on my table, but if I just repeat the pattern and just keep bringing it back, I'm going to get another vertical asymptote right here at negative pi over 2. And so keeping in mind that I have to go through these points and I have to approach these vertical asymptotes but not cross them, here's the shapes I get. We've evolved. We've gone from, let's go ahead and just extend it this way as well. We've gone from snake on a plane to, yeah, snakes on a plane. So that's what tangent looks like. I'm not lying. I'm not going to hit very much on these key features. I'm definitely not touching on stretch factor. I can show you about that later. But one thing I want you to notice about tangent that's a little bit different than sine and cosine is that the period is just going to be this long. Because look, once I go to the next one, I've started a new snake. So the period is just going to be the length of the snake. And so the period is just going to be between these vertical asymptotes or between the next vertical asymptotes. And so this distance between these, if I take half a pi this way and then half a pi coming back, the period's only going to be pi units. And then the asymptotes that I drew were at all of these pi over 2s. Oops. You'll hear me call it odd pi over 2. That's a good word for it. The next one will be at 5 pi over 2. So every odd pi over 2, I'm looking to have a vertical isotope. I want you to really key in and focus on this, okay? Because these isotopes are going to be the absolute key in order to be able to graph these correctly and graph them accurately. So let's try one. You know how I feel about making up my own examples. I'm a lot braver doing it just in front of you guys than I am making a video with it. So let me do this one I've done in the past to help you out. Tangent of, let's say, 2x plus pi over 2. That's right. I'm breaking out all the stops. I'm breaking out anything's fair game, A, B, C, or D. We're not going to kind of piddle around with this. We're going to get this done on this video because it's going to be that easy. Now, what I'm going to do is I'm first going to find the isotopes. Okay, so the isotopes are going to come from this middle part right here. What I'm going to do is I'm going to take this middle part, 2x plus pi over 2, and I'm going to set it equal to where that first isotope was on that tangent function. I'm going to call it the mother tangent function on the last slide, the one that I boxed in. Well, that first isotope was at negative pi over 2. Okay. And I'm just going to solve this for x. And so if looks like I'm subtracting pi over 2 from both sides. I think I'm just going to work a little circle here. And so it gives me 2x equals, well, if I have negative pi over 2, and I subtract off another negative pi over 2, I'm just subtracting off pi over 2 rather, I have negative 2 pi over 2, which is just negative pi. Divide by 2. I found my first isotope. I'm just going to put it right here and label it negative pi over 2. And I'm going to do all this again, but this time, I'm working this in a really weird spots. I don't need all this room. I'm going to take what's in parentheses right here, and I'm going to set it equal to where the second isotope was on that mother function. All right, I almost said something bad there. That mother tangent function. All right, hope you guys get a chuckle out of that. So the second one that I boxed in is going to be pi over 2. And again, I'm just going to solve this for x. This math's going to be a little bit easier. Yeah, divide by 2, I get x equals 0. So I'm going to have another one right here at x equals 0. I can't really label that. I guess I'm going to put a 0 there. And so I'm ready to draw my snake. My snake's just going to come up. It's going to go it's going to cross halfway between these, and it just traces up. Now my rule on all these have been so far, draw 2 hills and 2 valleys. That gives me 2 periods. My rule is going to be the same on this. I need 2 snakes. And so however far I came over, I'm going to come over that far again, which means that pi over 2, I'm going to have another isotope, and I can just draw another snake. This is full points. I'm not nearly as tedious on this tangent graph as I've been on sine and cosine. I'll give this full points and go on to the next problem. Okay. All right, if you didn't quite get that, the good news is cotangent is going to be so similar. The bad news is I'm going back to square one with it. So I'm going to start with this little line bothering you guys. I'll get it for you. I'm going to start with the xy right here. And again, I'm going to go from 0 all the way down to 2 pi. I'm going to switch colors because it takes a little bit. I already messed up. Yeah, I would stay on the white this time. Yeah. after I switch colors. Now you're going to see a lot of similarities to the tangent graph, but remember on the cotangent, I've got to do x divided by y this time, because for cotangent, it's going to be cosine divided by sine. So you guessed it, I'm going to have some vertical asymptotes everywhere that sine x is equal to 0. Let's figure out where those are. Well, it happens right off the bat, doesn't it? This very first one, if I take x divided by y at 0 radians on my unit circle, I get undefined. Okay, cotangent of pi over 4, that's 1. Cotangent of pi over 2, again, grab that unit circle, take a gander at it, hit pause on the video. That's going to give me 0 divided by 1. That's perfectly fine. I get 0 there. Cotangent is going to be -1. Oh, another undefined. I divided by 0 right there. I had to point -1, 0. -1 divided by 0 does not work. And then I'll just give you my hint. It repeats over and over and over again, which is why I don't need a table. But let's go ahead and graph this to see what it looks like. Right off the bat, I see I have an undefined. Okay. Let me see what I'm counting by here. I'm going to count by pi over 2, and then this would be pi, and then this would be 3 pi over 2, and we'll throw 2 pi right here. And I'm going to throw 1 here and -1 there. So right off the bat, I get something undefined. That means I'm going to have a vertical asymptote right there on the origin. All right? It goes through the origin on the y-axis. So keep that in mind. I got an isotope there. I'm just going to go and label my isotopes first. 0 and pi. Those are my first two that I'm going to be using going forward. So I'm going to have another one at 2 pi, 3 pi, 4 pi. Every multiple of pi, I should be looking at having a vertical asymptote there. Okay, so I got another one right here at 2 pi. Okay, I'm going to go through and put my points down. Let's see, at pi over 4, I'm at 1, and I'm at 0, and -1. 1, 0, and -1. We'll extrapolate just a little bit. There we go. So if I draw what this looks like, remember, I've got to approach the vertical asymptotes. I have to go through these points. Yeah, look at that. My snakes are just going the other way. That's one of the differences. And it doesn't just stop there. It goes on 1, 2, 3, 4. It goes on this way as well. I would have snakes. They go on forever and ever in both directions. Okay. There's that. Period's still going to be pi. That's still, the period's going to just be the width of one snake on this graph. And then that's cotangent. But you can see the difference with this. My cotangent graphs, they're going up to the left. And then you see that I'm not using negative pi over 2, but I'm using 0 and pi. Okay, so let's graph one, and then we're going to call it a day. I'm going to graph y equals 2 cotangent of 1/3 x plus 1. Trying to make it different so that you've seen, I don't have to work a ton of examples on here. You'll have something to refer back to. Again, no table on this. I know it's going to be a snake that goes up and to the left. I just got to get my vertical isotopes in the right spot and draw those snakes in between them. And that's really all that I'm going to be checking whenever I go to grade this. But I don't think I'm going to make it so that your isotopes are in the same spot every time. For instance, look at this one. If I take this 1/3 x and I set it equal to where that first isotope was on that cotangent function that we just did, it's going to be at 0 instead of negative pi over 2 this time. It's at 0. I'm going to recap that in just a minute. Multiply both sides by 3, and I still get 0. So actually, this one did not move, but I assure you the next one will. All right. The next isotope on the function was at pi. Okay, so I'm going to set this parenthesis equal to pi, and it will take care of the stretch and the shrink and the shift and everything else, and multiply. My next one's not going to be until 3 pi. 1, 2, 3 pi. So draw an isotope there, label it for me. I'm going to tell you, I hardly ever worry about this 2. Okay, I'll kind of show you where it comes from, but I am going to worry about this 1 right here. That 1 means the same thing as it did with sine and cosine and what it did in the first semester. It means that everything's going to move up 1 unit. That means that the snake is going to move up 1 unit. That it actually won't cross over at the axis, but it crosses over 1 unit up. Okay. And I need 2 snakes. 1, 2, 3, 4, 5, 6. And they're all going to be equally spaced apart. So if this one's 0, that one's 3 pi, this one's going to be 6 pi. It got moved 1. I thought that was weird. Were you guys not going to tell me that I drew that weird? Sorry, this is where I could pause the video, but I want you to see I make mistakes too. No big deal. That is a 3 pi. That snake is going to cross over halfway between it and 1 unit up. Let's just put that guy. There we go. Halfway in between and 1 unit up. So if we're getting technical about it, it's been stretched by a factor of 2 right here, which just means that when it comes halfway across, which would be right here, I should be 2 units up. So I drew it just about right on there. When it comes halfway across right here, I should be 2 units down from that midpoint. Again, I'm not checking that, but I actually did really good graphing. I kind of missed this one right here, but that's nothing that's going to be checked. Don't worry about labeling a y-axis on this. I'm worried about snakes going in the correct direction and your isotopes being in the right spot. Okay? All right, that's it. Here's some great practice problems for you to do. These don't take very long to graph, so if you have questions, send me an email, comment on the video, let me know what you got. I'm just going to do a recap real quick. Recap. So for tangent, I'm going to use negative pi over 2 and pi over 2 to find my vertical isotopes. So whatever's in parentheses, whatever comes to the x, I set equal to negative pi over 2 and pi over 2. And my snakes go up to the right. Whereas the big difference for cotangent is I'm using 0 and pi to find my vertical isotopes. Again, what does that mean? That means that whatever comes with the x, just like on that last example, I'm going to set it equal to 0, solve for x. That will tell me where the vertical isotope is. And my snake runs up to the left with that one. Okay? All right. I hope we get to teach this in class. It's so hard to learn from a video, but under 20 minutes, I think I did pretty good as far as getting the point across. I'll see you guys next time, and goodbye.